Dear students, welcome to lecture number 16. Today we'll be discussing two-element three-phase energy meter. So as the name suggests, this particular energy meter is used to measure energy consumed in a three-phase load. So we have two elements. Two elements in the sense we have two set of very similar single-phase energy meters which are connected in some particular manner so that you are able to measure this three-phase energy. So remember, this is used for three-phase, three-wire system, and you have three element meters which are available for three-phase, four-wire system. Okay, so which is not in the syllabus. So remember, this is only for three-phase, three-wire system. Now, as I've already told, we have two elements. So this is one set of single-phase energy meter, and this is another set which we already have seen. So the construction is very similar to that. The only difference is that we have two sets arranged in a particular way. So here you can see that you have two discs which are mounted on a single shaft or a single spindle, and we have all other arrangements provided. We have the brake magnet. So here the brake magnet is provided here, and then you have the U-shaped series magnet or the current coil magnet. Two of them are here, so it is also provided here. So this is your current coil magnet, and then you have M-shaped pressure coil. The M shape is not shown here, but actually you have the M shape available. So in order to show different wires, we have omitted the shape of the shunt magnet or the pressure coil magnet. So M-shaped magnets are also provided. That also you have two in numbers. So these are connected in this particular manner so that it is able to rotate together due to interaction of the fluxes and the currents produced in individual discs as well as the torques produced, and these torques will also be applied on these individual discs which will be allowing this spindle to rotate in a uniform manner. We are also provided with the braking arrangement, and also the arrangements like copper shading and such arrangements are also provided, but they are not shown in this particular figure. So all the arrangements which are required for single phase energy meter is provided in this also. So your once the same amount of current is power is passing through the same set of two set of energy meters, it should provide same torque, same driving torque to the disc. So your disc will be rotating in a uniform manner. If you have uneven driving torques, that will be causing vibrations and it will be causing errors in the reading. So in order to adjust the torques, the current coil is connected in series and the potential coil are connected in parallel. So the torque will be adjusted before the connections before the operation is done or before it is ready for taking the readings. So the calibration is done in proper manner such that the torque on both the discs are equal, and the balancing torque or the stopping torque or the balance torque provided by the braking magnet or the braking torque is provided by the braking magnet is obtained before testing the meter. So that is also tested and proved, and continuous rotation or a steady rotation of the two discs are tested, and then later it is sent for to be supplied. Now the position of the compensator as well as the braking magnet. So this is your compensator is also provided just as I have told. You have the shading bands. So these compensators as well as the braking magnets can be adjusted to obtain the balance torque as well as the your driving torque. So your driving torque as well as the braking torque can be adjusted by adjusting the position of different elements. So those are adjusted beforehand, and then once everything is in balance, we can operate the meter. So you can see that this is your current coil. So here this is one phase. So the current coil is connected in series with this particular phase R. Okay, then you have another set of current coil which is in B phase. So the circuit diagram will be like this. Then you have connected the potential coil or the pressure coil across the Y phase. Similarly, so this is between Y and B. Y and B it is connected, and this particular pressure coil is connected between these two phases R and Y. So Y is a common point. One is connected between Y and B. So this is one pressure coil point or the tapping point, and this is the other tapping point. So this is between R and Y, and this is between Y and B. So the power as well as the energy is calculated individually, and the net torque provides the net energy that is being consumed from the number of rotations. Now, just like in your normal energy meters, these are subjected to different errors while they are being operated, and because of the greater weight of the moving parts, the frictional errors are more when compared to single phase energy meters. Then some of the advantages of uh, this a single unit of three-phase meter is that it is cheaper than having three single-phase meters. You can also think of like connecting three single-phase meters separately in three phases. Okay, and this will be more costlier when compared to connecting a single three-phase meter, just like we have done. So again, here the total power or the total energy will be indicated in separate dials. So you'll have separate dials, and this will be indicating in three separate dials, and you have to manually add up everything. So here you can indicate your total power in a single register or a single dial. In case of inductive loads, after or below 0.5 power factor lagging load, your power reversal happens. So that is one of the uh, uh, nature of the power which when you are trying to measure power using 2 wattmeter method. So you have already seen that. Okay, you have a power reversal happening, and you have to reverse the current coil connections in order to obtain a uniform, in order to obtain a positive power. So what happens if you are using two separate energy meters? You will have one of the meter read value will the total 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 value will be reduced. One total value will be reduced. One total value will be reduced once you have a negative integration. Okay, once you have a negative sign of integration, it will be reduced from your total value. So the net energy consumed will be erroneous. But in case of this meter, even though you have a power reversal happening, the torque in one of the element where your power is still positive will be more than the torque in the other element, so that your net torque will be positive. So since the net torque is positive, the meter continues to show positive reading or your positive kind of energy. So the while during the integration or during integration process, there is no issue. So still your energy is being added up. Okay, but if you are using two single phase meters instead of single three phase meter, one of the meters will be showing negative integration. That is, the values will be reducing than the previous one instead of increasing. So that will cause some errors. So it is preferred that you go for single three phase meter, which is having either two elements or three elements for three phase power measurement. Now this whatever we have discussed is based on induction type working principle, induction type three phase energy meter. Okay, so the working principle of this particular three-phase energy meter is very similar to your single-phase energy meter. It is electromagnetic induction, and whatever the explanation that we have done for single-phase energy meter is valid for this also. Only thing is that you have to connect two energy meters in a particular manner so that you are able to measure energy for the three-phase system. Thank you.